A very good evening and welcome you all to this session of the webinar series organized by the Skywatchers Association of Kolkata. To start off today's welcome address, I better start with a famous dialogue, a famous one-liner rather. That is, that's one small step for man, one giant leap for mankind. This single line uttered by Neil Armstrong changed everything, changed our perspective of space exploration. What did basically start with a space race between two nations ended up basically with the victory of science. What did it result in? We could dare to think beyond our limits. We really could dream to touch the sky. The foundation stone for space exploration was laid. The Apollo missions, if one has gone through them in detail, they are so fascinating. The systematic approach, the series of thorough planning, and the stage-by-stage enhancement of the whole project is an example in itself. This entire endeavor culminated on the 20th of July 1969 when two representatives of the mankind, humans, landed on the moon, set their foot on the moon for the first time. This was the achievement of science alone. Now, the Apollo missions, as we talk about them, give rise to a new era. They basically ushered in the development of new technologies. Some of them are like, say, integrated circuits, freeze-dried food, fireproof material, power tools, not power tools basically, cordless tools, digital flight controls, etc. Now, we are basically using many of those technologies in our day-to-day activities today. In our homes, we have drill machines, we have freeze-dried food stuff, we use fireproof wire, etc. So that was an era of when science started with the development of this technology started with a bang. Now we have it indoors in each and every home. After that, we come a long way. And now I'd like to quote a very interesting line by Stephen Hawking. He said, "We are just an advanced breed of monkeys on a minor planet of a very average star, but we can understand the universe, and that makes us something very special." Now, this thing, what does this specialty impart upon us? It says that it leads us to think that we can think and comprehend. We try to understand nature step by step. We try to know our bearings or to address where actually we are in this vast cosmos. These questions finally lead us to one very important thought. What will be the future of mankind? We know that the sun is aging. It has, say, another 500 crore years. And our mere existence depends on it. So what happens when the sun runs out of fuel? Naturally, we're going to run out of life. What will remain is a barren, charred, desolate, lifeless earth. So what are we going to do? Where do we go? Whom do we look for help? Whom do we send an SOS to come and help us? We are in trouble. This is to be kept in mind that there is no one there to help us. We are on our own. We shall have to come up with some ways to protect life and help it flourish. Maybe somewhere else, maybe someplace else. Now, really, we do not have anyone to look up to for help, but science. That is the ultimate truth. We have to look to science. Keeping in tune with this notion, let me welcome Dr. Jaydeep Mukherjee, Director, Florida Space Grant Consortium. We have to keep in mind that he is at NASA and we are here. In spite of the 9.5 hours time gap, he has agreed to start a very early day so that we can attend the webinar today at 5 p.m. Welcome, Professor Mukherjee.
Thank you.
Now, this lecture is unique. It's on a unique NASA project, Artemis, its goals and its implications, which will be delivered by Dr. Mukherjee. Now, as usual, we have a social responsibility from which I must ask everyone of you to be safe. Please follow the guidelines issued by the governments to be safe from this pandemic. Wash your hands regularly, wear a mask whenever outside, use hand sanitizers, and just be safe. Dipankar, over to you. Thank you.
Thank you, sir, for a wonderful introduction to our webinar, our 5th webinar actually. We are fortunate enough that Dr. Jaydeep Mukherjee is present amongst us today. We can only express our gratitude to Dr. Mukherjee for sparing us his valuable time. Dr. Mukherjee is the director of the NASA Florida Space Grant Consortium, which is led by the University of Central Florida and administered by the Florida Space Institute. Dr. Mukherjee received his bachelor's degree in physics from St. Xavier's College, Mumbai, and master's in physics from Mumbai University. His MS and PhD degrees in astronomy is from the University of Florida. Currently, he is serving on the board of directors of the National Space Grant Alliance and is a member of the Commercial Space Operation Advisory Panel at Embry-Riddle Aeronautical University. In 2011, he received the National Eminence Award from the National Education Society of India. As a team member of the Radio Jove team, he received the Team Group Achievement Award from the NASA Goddard Space Flight Center for Excellence in Outreach. He was also awarded the Carrick Prize by the Astronomy Department at the University of Florida for his commitment in public education in astronomy. And the list just goes on. His research interests include synthesis of observable quantities for interacting binaries, understanding binary star mass transfer, mass loss, and formation of particularly interesting or unusual close binary stars. We are honored and privileged that, sir, you have accepted our request to deliver a talk today in this webinar. But before I hand over the session to Dr. Mukherjee, again, I should read a few instructions for the participants who have joined this webinar. First of all, please mute your microphones and turn off your video during the lecture session. Please do not ask questions in between the lecture. If some question popped up in your mind, please post it in the chat box, and we will ask those questions at the question answer session after the lecture session. When sir will present, you will see a tab in the list of the people headed presentation. You can see the presentation now also. Please click on the presentation tab and select pin to screen so that you can see the presentation without having any hiccups. If there is any connection problem, maybe there be some internet problem or so, please post it in the chat box. Wait for 2 to 3 minutes. Probably we will resolve the issue, or we will try to resolve the issue as soon as possible. Please bear with us in that case. And one more thing I should mention, that at the end of the session, we will provide a feedback form link in the chat box here and the YouTube live stream also. Please fill that feedback form and submit it, because on the basis of those received feedback forms, we will issue the e-certificates of this webinar. So without prolonging this introductory session, it is my privilege and honor to request Dr. Jaydeep Mukherjee to take charge of the session and deliver his talk. Sir, please.
Thank you very much. So please let me know if you can see my screen. I don't use Google Meet. So can you see my screen?
Yes, sir.
Yes,
We can
sir.
see it.
Okay, great. So, well, thank you for allowing me to talk to you. I was born in Kolkata a long time ago, but they kicked me out as soon as I was born, and I grew up in Mumbai. And then, but I visit Kolkata every year, and I love that place mostly because of its food and the people. But what I wanted to say, one thing I wanted to clarify is that I'm giving this talk as an individual, not on behalf of NASA, not on behalf of my organization, but as an individual. I have to say that. The talk that I'm giving is not based on my research work. In fact, what I do through my organization for the last 25 years, I've been providing fellowships and scholarships to students, research funding to faculty in Florida universities, and a number of our projects includes CubeSats going around the Earth, CubeSats built by middle school children, 5th to 8th standard students. I have experiments in the space station from school students and college students and faculty. Some of our students have built rockets and built payloads that fly in rockets. So what I do the last 20 years is I've been giving funding to researchers in Florida universities on a variety of topics connected to space, which includes space psychology, space medicine, astronomy, astrophysics, geology, planetary sciences. So what I'm going to talk to you today is not basically what I do or what I'm involved in, is what NASA is involved in returning to the moon. There are some projects which I'm supporting over the last few years regarding this topic, and I'll give you a small example later on. But what I wanted to do was give a quick outline. I'm going to talk about why we explore. This is a question I get from everyone. Why are we exploring? I'll give it a brief outline about the moon, its formation, its features. I won't go into detail. Then I'm going to talk about the Artemis program, which is going forward to the moon to stay, and why we are doing it. What is Artemis? Why are we going? What's different this time as compared to Apollo? How are we going to get there? That's one of the most important things for this talk. I'll talk about the Orion spacecraft, the Space Launch System, which is a rocket that will take us to the moon, the Lunar Outpost and Gateway, which is kind of fluttering right now, but I'll talk about that. Lunar landers, both human rated landers and landers carrying payloads, and spacesuits. There's very new spacesuits now for this mission compared to the Apollo mission spacesuits. Then when are we going? And this is something that our institute, the Florida Space Institute, is working on is moon dust and the problems for future lunar explorers. I want to focus a bit on that because no one talks about it so much, but we are working more on this because it's going to be a policy issue in the future, as you'll see. But moon dust is going to create a lot of problems for future missions to the moon. And I'll tell you what, especially one scientist called Phil Metzger, who was at Kennedy Space Center before we joined our institute. He's been working on this lunar dust problem for the last 20 years. And I'm going to talk about his results on what problems will the future explorers face and how we can mitigate it. And then I'll gladly answer questions, or later on, you can always email me with your questions. So I'm going to always start with this slide, and I like this because it gives you an idea of how insignificant we are. So we are currently on a 4.5 billion-year-old spaceship, a spacecraft, which is the Earth. It is organic, it's very complex, and it's self-sufficient right now. Who knows in the future what's going to happen. We are orbiting a power source that is 1 million times larger than our ship, and we call it the sun. There are more than 200 billion power sources like that in our group, which we call the Milky Way. In our neighborhood, we have 40 more groups like the Milky Way, which is called the galactic neighborhood. And then just to give you an idea, our galactic neighborhood is moving at about 2 million miles per hour to an object that is about 150 million light years away. We call it the Great Wall. So the whole idea is welcome to life. It's more exciting when you think on a larger scale. So that's currently what we are. And as it was introduced in the beginning, we are a civilization on an average planet around an average star. And I know some talks you had in the past about planets or other stars. We think there are more than 5 or 10 billion planets in our galaxy itself. So chances of life on other planets has to be high. We have no evidence for it, but we are working very quickly on that. That's another talk. So why do we explore? And I can say that we have two types of exploration. One is we explore because we do not know what we are going to find. We will find it when we see it. That was more in the past than it's going to be now. But the second thing is we know what is going on and we want to test our hypothesis. Okay. So, for example, take Newton's laws of physics. Do you see many new textbooks on that? No, because they have been kind of established. But suppose you want to talk about, say, consciousness. It's a very abstract topic. We don't know whether it's there or not, but now they have a lot of publications on consciousness because we still do not know what's going on. So we have some ideas, some hypotheses we want to test. And when we say explore, I don't mean exploring just space itself. It could be exploring land, it could be exploring the ocean, or exploring the mind. So we explore, and we need to explore because as a civilization, I think if we don't explore and we don't ask questions, that's the end of a civilization. So we need to explore, we need to answer questions. The other thing is, the future of humanity. I'm not trying to be bleak out here, but let's say, over the last 4 billion years, 99.9% of all the species are extinct. And that's a crazy number. The typical lifespan of a species is 10 million years only, and that's a wink compared to a geological timescale. So that's the typical lifespan of a species. On Earth, remember this, extinction is the rule, survival is the exception. So we have survived for the last 10,000, 15,000 years, but who knows how long we can survive on Earth itself. That's why one of the things we need to do is to explore and figure out other ways to settle on other planets or other moons or on asteroids. And of course, scientific advancement also has problems. So you can use new technologies to basically extinct the human race, whether it's biological or chemical or nuclear. So scientific advancement is very good. We need it, but if it's not used properly, it could be a major problem. And then, people talk about global warming and climate changes and so on. If you look at this in 2018, a hurricane washed away a remote Hawaiian island. Some months before that, Russian scientists reported a small Arctic island has disappeared, only remaining waters at that site. And then on the coast of Japan, there was another small island which couldn't be found. Maybe it's sunk under the water. So it's a grim thought in the future that this climate change is going to cause major problems, especially to coastal cities like Mumbai, Kolkata, Madras, Chennai, New York, Miami. It is going to cause problems. You're already seeing sea rise. And that's why it's so important, that the citizens of the world understand what science is. They don't have to be scientists, but they need to understand what science is. And they need to elect politicians who can use science to help humanity. And unfortunately, the trend is being reversed in a number of countries in the world. And it's up to us really to see that we educate the general masses if possible, and everyone is knowledgeable enough to make informed decisions. The other thing that I've noticed around the world, not only in the US and India, is that everyone thinks they're entitled to their opinion and we should respect that opinion. Sorry, that's not true. You know, I don't have to respect opinion because the opinion can be totally wrong, and they expect that their opinion should carry equally as an expert, a scientist, or a doctor, and that has caused a lot of problems with local politicians, with and the local public. So the future of humanity, I think it's good. I think it's okay, but we really have to think about trying to go to another object in a solar system, whether it's a moon or whether it's an asteroid or Mars. But we can only do that step by step, taking baby steps. So the first thing is to go to the moon, figure out how we can survive on the moon. And from there, maybe then try to live on an asteroid and then go to Mars. Mars, it takes some time because there are a lot of issues going to Mars. The radiation just taking, it'll take about at least a minimum of 6 months to go to Mars. And the radiation on the way will basically kill us in the future. So we still don't have a way to stop the radiation. So I think a lot of the countries are focusing on going back to the moon because it's only a couple of days journey to go to the moon. If something goes wrong, we can send other spacecraft or we can bring the astronauts back. If something happens on Mars, it's at least a 6-month journey. So I think we have to, and that's why we're exploring. We explore because we want to protect and understand our world. We need to inspire the generation right now. That is so important. And that's what I've seen happening in India the last 10 years, with ISRO now trying to be more proactive and working with the students. Students are going to get inspired. They want to try and come up with innovative ideas, which helps new technology, which helps the economy of that country. So it's important that we do inspire the generation coming up right now. And I think on a positive note, that is happening very well in India right now. We always would like to answer unknown questions. That's within us. Are we alone? Are we the only civilization in this galaxy, or this universe? I doubt it. But we have no evidence for it. So we want to figure out, are we alone? The other thing is international collaboration. No country in the world can really do a good job and everything by themselves. China is doing it a bit, but usually most of the countries are collaborating because that's cheaper and it's a quicker way of doing things. And of course, I think a long-term survival is very important for these exploration requirements, because the Earth is being bombarded regularly with small fine dust. But every day or every other week, we hear about a new small asteroid or a meteorite being discovered which goes past the Earth. Not very close, but pretty far away. But there could be a time when we have one that is going to come and hit the Earth again. And of course, we have problems with water on the Earth, food on the Earth. So a long-term survival, we really need to explore and figure out technologies, figure out means of where we can go. And at the end of this talk, if I have some time, I'm going to show you a 3-minute or 4-minute video called Wanderers, which I think are going to be a future 50 to 100 years from now. So someone talked about the benefits of space exploration, and this, I can talk for hours on that, but just to give you some quick idea about some of the benefits of space exploration, the spin-offs from the technology, from your cell phones to pacemakers, to advances in heart pump, the GPS system, diapers, hip replacement. Of course, everyone knows about Velcro, fabric, battery technology, the radiation blocking lenses, and so on and on. Can go on and on about the benefits of space exploration. There are numerous. Here's another a graphic which kind of shows you so many things that has happened as a result of spin-offs from space technology. Not just in the US, but in other countries around the world too, including India. And it's varied from different places different things that we use, and I won't go through it. So the worlds that we have explored, where have we gone? So we have landed on, when I said landed, I mean robotic landing. We have landed on a comet, we have landed on an asteroid, we have landed on the moon, we have landed on Venus, we have landed on Mars, we have landed on one of the moons of Saturn called Titan. That's a very interesting moon, Titan. I'm really excited about this moon because there you have methane, which is, you know, carbon and hydrogen in 3 different forms, liquid, solid, and gas. Like we have water on Earth in 3 different forms. Titan is a very interesting object that we want to go. In fact, there are lakes on Titan, methane lakes, where we think there could be, you know, some kind of organic molecules at the bottom of the lakes. And one of the things that NASA is trying to do and has asked for proposals is to send a submarine to one of these lakes on Titan. But as usual, as in the case everywhere, you know, who makes a priority of where to go? Where's the funding going to come from? And that's always an issue, especially here in the United States. Whenever you have a new president, the new president chooses a new administrator for NASA, and the whole goals changes. So we have this problem that we don't have this continuity, and then every administration comes up with their new ideas on what to do. Politics was a major important role in space policy and what we do. I would love to go to Europa, which is one of the moons of Jupiter. We know there are a number of moons now, including an asteroid called Ceres, where we think there is water, liquid water underneath the surface. Enceladus is another object. We also know Pluto. We think Pluto also has a liquid ocean underneath the surface. So we would like to visit all these different objects in our inner solar system, not just to explore, but also to find a way to settle. This is an eyesore, but just to give you an idea of how many times you've visited other objects in the solar system. And of course, the moon is the one that visited the most, is very close to us. We have Mars, we have Venus, then we have Jupiter, Saturn, Uranus, Neptune, Pluto. We visited comets and asteroids and so on. So we have explored a lot, mostly robotic. We hope to go back to the moon again and then land on Mars in the future. So we are going to explore space in partnership. Right now, we use the International Space Station, which is orbiting about 400 kilometers above the Earth. Then we want to somehow have something called the cis-lunar space between the Earth and the Moon. Maybe have another kind of small space station like the Gateway that I'll talk about. And once we figure out how we can stay on the Moon, how we can use the resources on the Moon, either to build habitats or to create water or to create fuel, then we can figure out of going to Mars and use the resources on Mars and settle on Mars itself. But I think that's going to take some time, in spite of some people saying that they'll be going in a few years. It'll take some time if we want to survive once we go there. So I'm going to switch now. I'm going to go and talk about the Moon a bit. Just to give you an idea about some of the formation ideas and some of the features on the Moon. I won't go into too much detail because talking of the Moon will take a few hours just to give you an introduction to the Moon itself. So here's the Moon, which is the national satellite. We have had 24 human visitors. 12 of them have landed on the Moon. The rest have just gone around the Moon, including the ones which did not land at all, like the Apollo 8 and so on. These are the landing sites on the Moon. The ones in red or pink are the ones that where humans have landed, and the greens are the. This is actually, it's called a lava tube, and this is making very news right now. Lava tube is kind of a tube because of volcanism underneath the lunar surface. We have lava tubes on the Earth too. The reason we think it could be interesting is because if we can have habitats inside this lava tube, it'll shield us from radiation and from extreme temperatures. So they have found a pit, a broken surface on the surface where we can look at the lava tube inside. And maybe in the future, that's a place that we can settle. There are a lot of problems with that, but that's another story altogether. So I want to just point out the lava tube pit is actually the top of a lava tube which was broken because of an asteroid impact. The moon has almost no atmosphere, so it is bombarded by asteroids and meteorites quite constantly. Here's another human and robotic landing sites. Look at this. Remember this lunar Apollo 15? I'm going to talk about this later on in the talk about the Apollo 15 lunar site and the Apollo 12 and the Surveyor 3. When I talk about the issues because of dust, I'll talk to you a bit about the Apollo 12 mission and the Apollo 15 mission and the problems with that. But here are all the places where humans have landed, and the ones in yellow, this is the Chinese which have landed on the moon, the Russians, and of course the US, along with some of the robotic landers. Here's the selected moons of the solar system to scale compared to the Earth. I hate people memorizing numbers, okay? Big, huge numbers. It doesn't help at all. It's always good to think about it in a comparison, remember it more. And it's more effective than coming up with a huge number like 10 million miles or 500,000 kilograms and so on. In this case, just a good picture will give an idea how big the Earth's moon is compared to the other moons in a solar system and the Earth itself. Given that, I still gave you some numbers because some people like to look at numbers, but I look at the mass. So it's a huge number, but I say it's about 100 times that of the Earth. The diameter is about 3,000 kilometers. The density is about half of that of the Earth. Look at the surface temperature, ranges from -200 to +100 degrees centigrade. And the surface pressure is almost negligible. It has almost no atmosphere. Here's inside the Earth's moon, we have a solid iron core. It's very small compared to the Earth. There's a partially melted outer core, and we have a crust and a mantle. The gravity is about 0.17 times that of the Earth. So if you can jump 10 feet on the Earth, you can jump about 60 feet on the moon. The temperature range, as I said, is extreme. And the moon is about, diameter is about 1/4 that of the Earth. So it's very small compared to the Earth. Some of the features on the moon, and with the naked eye, you can see some of the features. The dark areas that we see, we call them the Maria or the seas, because in the past, hundreds of years ago, people thought that there were oceans on the moon. That's why it was dark and they were called seas. And they have the highlands, which are more heavily cratered. Those are the older surface. The Marias of the seas are the younger surface. And then you see it's heavily cratered because there is no atmosphere on the moon and it's always bombarded. There's a lot of features on the moon. We talked about craters. You have rays coming from craters, which is basically ejecta, and you can basically see that during a full moon. You have the highlands, which are the mountain ranges around the craters. We have those rills or the valleys from old lava depressions. And the rocks in the moon, if it is from the Maria, they're kind of dark, mostly granite. And if they're from the other parts, the lighter areas, you'll see the rocks are lighter in color because they're made up of silicates. I'm showing you one animation from the European Space Agency, and so when the moon was forming, it was molten, and what happened is all the heavier elements sank below, and the lighter elements of the silicates came to the top, and so on the top we have lighter material. But because there was lava at the bottom, below the surface, when meteorites or asteroids hit the surface, it cracked open, lava seeped out, and it cooled and formed these dark seas that we call. And you see, this is from the Maria. This is how dark is the rock, and this is from the other lighter areas. These are mostly silicates. This is mostly granite, igneous rock. So there's a difference in the colors. So that's the difference between the Maria and the Highlands. And I'll talk a bit of the Maria in the next few, after a few slides. There's another reason why the Marias are where they are, apart from the seepage of the lava which cooled. The other thing is the regolith. The regolith is another word for the lunar soil. And this is what's going to cause a problem. It did cause a problem during the Apollo missions, but if you want to go and settle on the moon, this is going to cause a problem, the regolith of the lunar soil. It's a layer of loose soil on the surface. It covers a solid rock. This is a regolith collected during the Apollo 17 mission and brought back to the Earth. It's very, very fine. It's finer than sand. And that's what causes the problem. And is mostly formed by the impact of meteorites on the body's surface. They're mostly about 1 centimeter in diameter or less. And so people talk about the lunar soil or the regolith interchangeably. So in the US, we have, for a number of years, we had an artificial lunar regolith. And we have that at the Kennedy Space Center. And we have competitions where students build rovers and they try to excavate this regolith in this bin, and it's very, very difficult because it's so fine. You know, India is also trying to build their own lunar soil or regolith. In fact, in our institute, we have the only place where we are actually manufacturing different types of regoliths of different worlds. So if you want a regolith from Mars or from the asteroids or from the moon, we are building simulants of these regoliths and we are shipping it out to anyone who's interested for science. Look at the spacesuit. This spacesuit was supposed to be white in color, but look how dirty it has become because of this lunar soil and dust. And the spacesuit is now in display in the Air and Space Museum in Washington. And you do see it's kind of grayish in color because of all the lunar dust. So quickly go and talk about the formation of the moon. Just to give you some science and astronomy in this talk. So I'll very quickly talk about the 4 different ideas that were floating around. The first one was called capture. And what that is that we thought that the moon was formed somewhere else in the solar system and was captured by the Earth. But the problem is that, they think that it had to have been in the right place at the right moment at the right speed to have been captured by the Earth. And so scientists don't believe in that hypothesis. So that capture hypothesis was thrown away. The second thing is called rotations. Some scientists thought that the Earth was rotating so fast when it was formed that a part of it broke away and formed the moon. But the problem there is that if it did break away, it should be very similar in composition to the Earth, and it's not. The moon's composition is more similar to the Earth's mantle, which is below the crust. And there's no evidence of fast rotation of the Earth in simulations that we know of. So again, that hypothesis was ruled out. The other one was called co-accretion, which means that as the Earth was forming with the same nebula, the moon also formed next to it. But if that was the case, if the moon was formed in the same area where the Earth was formed, then the moon's density and the Earth's density would be very similar. But we know that's not the case. The moon's density is about half of that of the Earth. It has a very small iron core. So the co-accretion idea was thrown out too. And finally, this idea about a collision, which happened millions of years ago, was finally accepted in the 1980s. And we think that a Mars-sized object had a sideways glance at the Earth, and the mantle broke away, formed a debris around the Earth, which later formed the moon. And this hypothesis was later confirmed as a theory from simulation and from observation, because it explains why the moon's density is less, it explains why the composition is a bit different. and so on. So this is a computer simulation which shows a glancing blow, not a head-on blow, but a glancing blow resulted in the mantle being ejected out from the Earth, which later coalesced and formed the moon. So in astronomy, you know, apart from observations, since we cannot have a lab on the Earth, we have to rely on computer simulation. So this collision theory is what we now accept as the formation of the moon. Now the other thing is, if we only see one side of the moon, so we call it the near side. The other side is called the far side, and it's not called the dark side. There's light over there. We call it the far side. So I'll show you an animation. Again, these are mostly for kids, so I know most of you are college students and know about this, but I just want to show you an animation which kind of explains if it ever works. There you go. This is again a cartoon. We know that the Earth was formed, a moon was formed by a collision. The moon was spinning very fast in the beginning, but because the moon was close to the Earth was more massive, there was a tidal bulge. The Earth kind of pulled on the moon. Of course, this is exaggerated. The elongation is exaggerated. But this tidal bulge, it was not in alignment with the Earth. If the moon was spinning faster than it rotated, then the Earth's gravity pulled it back. If the moon was spinning slower than its evolution rate, then the Earth sped it up. So within 1,000 years after the formation, the moon was tidally locked to the Earth, and we almost saw the same size side of the moon right now. We don't see exactly the same 50%. The reason is because the moon is in an elliptical orbit around the Earth. Again, this is exaggerated a bit. And also the lunar axis, the moon's rotation axis is a bit inclined. So we actually see about 59% of one side of the moon, and we don't see the rest 41%. And we call that the dark side of the moon. So basically the tidal locking of the Earth. And this is the case of other moons of other planets too. Most of them are tidally locked with the parent body. And here's the far side of the moon. The left one is an image of the near side, and the right hand is the image of the far side. And I wish I could see you and talk to you. This is more of an interactive thing, but if you look on the far side, image on the far side, you'll notice it has a very few marias, very few dark features, like we have on the near side. So why is that so? Why is the dark side more heavily cratered? Well, we think that the far side, not the dark side, sorry, I'm also moving to the dark side. It's the far side. The far side, we think that the crust of the far side is thicker than the near side. And I'll tell you why. But because of that, because the crust on the near side is thinner than the far side, when asteroids hit the moon, it cracked the surface and lava seeped out and formed the seas. Here is the crustal thickness from a satellite, and it shows. So here's the crustal thickness. Blue is almost 0, and red is almost 60. So you see right over here, it's mostly in the yellow and blue, but on the far side is mostly 50 kilometers thick, 60 kilometers thick. Of course, there are exceptions over here, but the thickness shows that there's more. The crust is more thicker on the far side than on the near side. Here is something called the distribution of thorium, which is a radioactive element. And I'll tell you why I'm showing you this, because it seems that on the near side, there are a lot more thorium and potassium and rare earth elements called creep in the rocks. They're radioactive. We find very little of that on the far side, except maybe over here in the south pole of the moon. And why is that? How does that help? So let's see an animation of why the crust is thick on the far side than on the near side. And we go back again to the formation of the moon. Here's the moon being tidally locked to the Earth, again exaggerated, but because it's showing the same face to the Earth, the near side of the moon was kind of a bit hotter because it was the heat from the Earth fell on the moon, while the far side was a bit cooler. So it cools slower than the near side. So the crust on the far side is a bit thicker than the crust on the near side. Also, these radioactive elements, they actually create heat, and so the rocks on the near side melted faster than the rocks on the far side because there are very little radioactive elements. And this creep, which is a way of saying that the rocks have potassium and rare earth elements, what they do is also they lower the melting point of the rocks. So because the melting point is lowered, the rocks melt easier on the near side than on the far side. So it's a combination of a thicker crust and radioactive elements that created the seas on the near side and not so much on the far side. And of course, this came out about 7 years ago in 2013. So this is just some pretty pictures I wanted to show you. The Japanese did not actually land, but a spacecraft called Kaguya went around the moon, and they took some beautiful high definition images and videos. It actually did impact the moon finally, which is sad. I don't think we need to impact any object onto the moon, whether India did it or the Russians did it or Japanese do it. We should not impact other objects onto the moon because we are very careful of actually trying to see that there is no bacterial life form on these satellites when they go to the moon or go to other planets. But we do not want to introduce life, whether it's bacterial or so on other objects. And just to do a sidestep, during the Apollo mission, Apollo 11, 12 mission, the excreta from the astronauts, they were kept in bags and they're left on the moon, by the way, because it was making everything heavier on the moon, especially when they wanted to get up on the lunar surface. Now, so you have these bags are very sealed, but you're talking about organic material inside these sealed bags. Who knows what's growing there? Who knows? We don't know. So I think, and that's why NASA has this planetary protection group or a division within NASA to see that, at least from the US point of view, that we are very careful not to introduce life forms on other objects. This is just a pretty video. It just shows the Earthrise as seen from the moon, taken by this Japanese spacecraft. This is a Japanese animation and video by JAXA, the Japanese Space Agency. And so this is
moves toward the South Pole on the far side of the moon. The blue Earth has appeared from the horizon. This is the Earthrise.
This is real.
By the telephoto camera.
This is not photoshopped or anything. And I worked with a number of astronauts, and everyone said, shuttle astronauts, everyone said that the first time they looked at the moon from the space shuttle, their life changed.
The sun is located right behind the Kaguya. The sun's light is projected directly onto the Earth, which appears round like a full moon. In this footage, the Earth's southern hemisphere appears on top. This is a spectacular view of the beautiful planet we call home.
I love this. So that's and here is a flyover of the near side of the moon. Look at the video. This is amazing clarity.
Along the eastern rim of Mare Imbrium, the Sea of Rains, and passes over the craters Artemis and Autolycus. Artemis is 55 kilometers across. When the crater was formed, the material that erupted from the moon's interior spread out in a radial pattern and created white lines, known as a ray system. Now you can see the landing site of Apollo 15, located near Lima Hadley. This is Monte.
Just remember the Apollo 15 landing
it's a
site.
rugged mountain range with peaks more than 5,000 meters high. Monte Sapininus, named after the Apennine Mountains in Italy, is more than 600 kilometers long.
So that's just to give you just an idea of how beautiful videos we can get of the moon. So why do we explore the moon? Now we talked about exploring this outer space. Why explore the moon? Well, one thing, we want to extend human presence onto the moon to enable eventual settlement. Remember, try to use the word settlement and not colonization when we talk about going to other objects. It's a better word to use. Scientific knowledge, we want to pursue understand more about the Earth by learning about the moon. And our place in a solar system. Preparation, test technology, and other techniques that we require to survive on other worlds. And it's easier to do it on the moon. I think this is the most important thing, global partnership, because it does unite nations, a common goal, and also unite the people of that country. So global partnerships is important. Economics plays a big role too. So, if we find very interesting minerals on an asteroid, they're going to have private companies trying to go and mine those minerals because they can be very, very expensive. So economics is going to play a big role. And that's why we have a number of private companies now trying to join the space race. And there's public engagement, Without the public engagement, it'll be tough for the government to fund these missions, whether it's in the US or India or Europe. I don't know much about China and Russia, but other countries, yes, the public does play a big role in supporting these missions. So now I go to talk about Artemis and the program. Remember, this program is still being built on. We don't have all the details as yet. And funding is going to be an important issue. NASA is not getting all the funding it has requested for this mission. So I'm going to give you what's going on right now, but the future, I don't know. We don't know. No one knows. I'll skip this. This is Artemis is a twin sister of Apollo. That's why they gave it the name Artemis, and that's the logo for the Artemis mission. So we are going to the moon, okay? Not just to go back again, but to prepare for Mars. That's eventually because Mars, has more of a gravity, has some atmosphere. We know there is water on Mars. We know there's water on the moon too, but there's a lot more water on Mars. So we want to go to the moon to prepare for Mars. And how are you going to go there? So we have to have architecture. We have a network of Earth-based structures for launching. We have a new rocket. It's going to be the most powerful rocket in the world. Right now, it's called the Space Launch System. It's not very imaginative name, but that's what the name is for the rocket. The spacecraft that is going to hold the crew, the crew is called the Orion Spacecraft, and that's going to be on the top of the rocket over here. Then we have the gateway, which is kind of a small space station around the moon. The idea is that spacecrafts from the Earth will go and dock with the gateway, and from the gateway will land under the moon. So there are lunar landers that will carry humans from the gateway to the moon, and I'll talk about that. And then, as a new generation of spacesuits, we cannot use the Apollo spacesuits to explore the moon and other planets, and I'll tell you why. So they have been designed for a broad range of movement. So NASA was given the charge. As I said, it's political. It plays a big and important role. So NASA was given the charge by the president to go to the moon by 2024. Whether that's going to happen, we don't know, because it all depends on funding. So the way it works in the US is that the president and the administration might say, this is what NASA should do. Then NASA then requests a budget from Congress, and it's up to Congress to support that mission. So right now, NASA does not have all the funding it requires to do everything. So politics plays a big role. But the whole goal right now is to land 2 humans, a woman and a man, on the South Pole by 2024. And I didn't talk about water on the moon because that's a big topic, but we have evidence of water on the moon, not in the form of lakes, but some of kind of ice on the craters in the South Pole where very little sunlight reaches. So we want to go near the South Pole and land near the South Pole because of the presence of water, we think, near the South Pole. So, you know, Chandrayaan-2, we tried to land near the South Pole for that very reason. NASA wants to land near the South Pole for that reason too. Again, it's the whole idea is moon before Mars, so that we can create the technology and test the technology on the moon before going to Mars. And again, the mantra, as you say, is we're going forward to the moon to stay, not just to come back, but to go there, figure out ways to utilize the resources on the moon, the lunar regolith. I have funded some topics, some projects in universities where they're trying to build cement out of this lunar regolith, use 3D printers on the moon. So use the resources on the moon, create water on the moon, because we have oxygen and hydrogen in the form of water molecules on the moon. So how can we break up them, use the oxygen to breathe and the water for everyday good? Again, work with commercial international partners to make this faster. I'll skip this. So how are you going to go there? As I said, we'll talk about the Space Launch System, the Orion Spacecraft, the Gateway, and the lunar landers. So here's the rocket. The rocket, it's almost built, it's almost done. It's called the Space Launch System. It's going to be a very big rocket. It's almost as big as a Saturn V, which took humans to the moon, but it'll be more powerful than the Saturn V. The SLS rocket will be the most powerful rocket in the world when it is done. And it can carry more cargo to the moon compared to the space shuttle, a lot more. So I'm going to show you an animation later on of the rocket because it's a very fascinating object, the rocket itself. And you know, it has to be tested and tested because it's carrying humans to the moon. So the main thing that gives the power to these rockets is called the solid rocket boosters. And these are the two boosters that, along with this liquid fuel, which actually provide the thrust for the rocket to leave the gravity well of the Earth. But these solid rocket boosters are the ones which gives it the more power. And we have these engines, 4 engines, which uses liquid fuel. And then you have other parts of the rocket. The top is called the launch abort system. If something goes wrong during the launch itself, there's a smaller rocket which can lift the astronauts away to safety. This is the crew module, Orion. This is called the service module, which has a power and propulsion. This whole thing is called the Orion multi-purpose crew vehicle, and so on. So rocket boosters, I don't want to go into detail, but it is about 5 segments. It's the most powerful solid rocket booster. Look at that, it's 17 stories tall. If you imagine, one story is about 10 to 12 feet. 17 stories tall. It generates more thrust than 14 jumbo jet commercial airliners. So these are really powerful rockets. And 170 feet in length, 12 feet in diameter, weighs about 1.6 million pounds each. And it runs for about 120 odd seconds before the solid rocket boosters will fall away. And then the engines will take over. But most of the thrust comes from the solid rocket boosters. But here's the problem with rocket boosters, with solid rocket fuel. Once you ignite it, you cannot stop the ignition. That is, it'll keep on burning. With the liquid fuel, you say you want to use a part of the fuel, you can regulate the amount of fuel that you're going to use, but not with the solid fuel. Once you ignite, it is ignited and you can't stop it. And here's the engines. We're using the same engines from the space shuttle, just modify it a bit. Again, if you like numbers, here are some of the numbers. The operation time is 8 minutes. So it's not 126 seconds like these rocket boosters. It'll operate for a longer time. Minus 400 to 600 degrees Fahrenheit is the operation change. Here's a quick video of the testing of the rocket itself, the rocket engine. This is by a company called Rocket Time, and here's the testing. So everything has to be tested and tested and tested because you're going to have a crew. I think this testing was done at one of the NASA centers called Stennis. NASA has about 10 centers. Kennedy is the only launch complex. The others do astrophysics, propulsion. Stennis is the one where they do a lot of rocket testing. Marshall in Alabama does the rocket itself. Goddard Space Flight Center does astrophysics. Jet Propulsion Lab does the planetary missions. The Armstrong Langley does aviation, and so on. There are 10 NASA centers spread around the nation, and that's where most of the work is done. So here is the testing of the rocket engine being done by Aerodyne. That is the company that has been given the task. NASA outsources a lot of its work. In fact, a lot of NASA science is outsourced to universities. I would say more than 70–80% of the NASA science is outsourced to universities. I'm going to skip this for the interest of time. But I like this one because this kind of explains the whole rocket and shows you how complex it is. And that's the Space Launch System rocket. So this is the progress. So here's the Orion Spacecraft on the top left. And the other one is the Space Launch System. So that's the launch abort system. I'll talk about that a little later on. That actually takes the astronauts away from safety. Then you have the Orion crew module where the crew is going to live there for the couple of days it requires to go to the moon. This is the European service module, which has all the propulsion and the food and all. This is the Orion stage adapter, which adapts the Orion crew module to the space rocket itself. The interim propulsion stage, liquid fuel. Again, another stage adapter. But look how big it is. Again, this is some kind of an adapter between the rocket itself and the first stage. Here's the liquid oxygen tank. So you have liquid oxygen, liquid hydrogen. Here's the liquid oxygen tank. There's a tank in between the liquid oxygen and the liquid hydrogen called the intertank. Here's the liquid. Look how big it is, this tanks. It shows you some humans in comparison. Here's the engine section. And I showed you a picture of the engine. Here are the engines, 4 of them. And they're the rocket boosters, 150, 170 meters tall, 70 feet. So this is the rocket itself, and this has been built for a number of years, and we're almost in the final stages of testing. I hope this video works because I want to show you that when they do the testing, they do exact replicas of the rocket, but they want to test it till it fails, because they want to see what is a failure, what happens when it fails. So this rocket, if this video works, hold on one second. Yes, this will show you the testing of the tank, and it's called structural testing. And they test it before the flight, and they push it to the limits of the structural integrity of those rockets. So they did almost 200 test cases, collected 400 gigabytes of data, but they wanted to test it till it broke to see what is the limit that these tanks will endure. This is done at NASA's Marshall Space Flight Center. These are actual real images. This is not an animation. So look at this one now. They're pushing the hard way until it fails. So they're deliberately wanted to do it. Look how it pops out. Again, this is sped up time, but it's real. So this is what happens, once the structure fails, but we're not going to experience that during flight. But they wanted to test it. So a lot of testing has to go on different parts of the rocket till NASA is very sure that it is safe to carry astronauts to the moon. I want to give a flavor of the testing that has been done. Then we have the Orion spacecraft. This is the artist's impression of the Orion multi-crew module. It has a number of different features, different parts. You have the abort system. This is where the crew stay, the crew module, the service module, which has a power generation, propulsion, consumables, storage, and then you have the adapter. This one, I like this small animation. It kind of tells you what's inside Orion. Orion is built by a company called Lockheed Martin. They have been outsourced to build the Orion spacecraft, and this is their animation inside the Orion crew system. So these are the seats and display of the 4 astronauts that can fit in that module. So they have shelters in case there's a solar storm. This is not going to the space station, which SpaceX did. This is going to the moon, where you happen to have a lot of dangerous radiation. This environmental and control life support that maintain the right level of temperature and oxygen and carbon dioxide. You're going to have a water machine and an exercise machine because you need to exercise, otherwise your bones become weak. Of course, there's going to be a toilet also for both genders, all genders, in a private cabin. So that, and those are the solar panels which just retracted. So that, in a nutshell, is the Orion spacecraft. And I think showing a video and animation is not more than talking about the various parts. And of course, this is where it was built in Louisiana, the Orion capsule. Look at that. Initially, the Apollo mission and even the space shuttle had analog controllers. Now it's going to be all digital, the controllers on the Orion spacecraft. And again, it's tested and tested and tested, the full-scale spacecraft testing. It simulates the launch acoustic forces, vibration, the structural integrity, because we're talking about human lives over here. So you need to keep on testing until everything is fine. We know the Orion capsule is going to actually splash down on the ocean. And so they do testing by dropping it onto a huge swimming pool to see how it's going to survive the fall. And they use the exact velocity that it's going to reach when it hits the water. We also tested the parachutes in Arizona because as the capsule comes down, it'll be in a parachute before it hits the ocean. I'm going to skip these things, but to talk to you, tell you quickly, the radiation shielding is very, very important because we're going to go to the moon, we're going to go beyond the Earth's magnetic field, so we'll be bombarded by very energetic radiation from the sun and from the galactic background, from the galaxy itself, cosmic rays. The best way to shield from radiation is have water around you, but you can't afford to do that. So we have to have materials which are rich in carbon and hydrogen to be very effective shielding materials. And you maximize the amount of material that can be placed between the crew and the environment. So radiation shielding is a very important thing. And right now, that's the problem we have, is to go to Mars, we need a lot more radiation shielding that we need to go to the moon, because we will be exposed to radiation more than 6 months. And I think that's a major problem we have is the radiation shielding to go to Mars. Here's a service module which provides the power and propulsion. I don't want to go through that. This is important, the launch abort system. It's actually a smaller rocket. It quickly separates from the rocket in case that there is a problem just after launch. And it's controlled both manually and automatically from the ground. So it's a solid fuel rocket above the capsule. It gives a large thrust for a quick, small amount of time to send the capsule away from the space for the rocket itself. And it has a parachute that can be deployed, and then it falls in the ocean. Remember, the launch is going to be from Kennedy. The launch is going to go over the ocean, and there's a reason why launch pads are near the ocean, because you want to carry the spacecraft away from land in case there is an explosion. You don't want debris to fall on the ground. So most launch pads are either near the ocean or deep internal where there's no humans around, like in Russia. So once it's aborted, the crew are ejected like in a military aircraft, and each of them will have a parachute return back to the Earth. So here's the concept of the operation. You're going to have, in case something goes wrong, either automatically or from the command center, is going to launch the smaller rocket, take the capsule away. The capsule will then jettison and fall onto the Earth. This is a long video, but I want to show you the actual testing done from the Cape Canaveral Air Force Station. I live in a town called Titusville, which is across Kennedy Space Center. So I can see all of these from my home. I just go out and watch all the launches. That's a good place to stay. Hold on 1 second. This one causes problems. 1 second, please. There you go. So this is a small rocket. Where they were testing the launch abort system. Here's the launch abort system on the top. And here's the launch from the Cape Canaveral Air Force Station is adjacent to Kennedy Space Center. And all the unmanned launches take place from the Cape Canaveral Air Force Station. So here you have this launch in early morning, sun just risen. This is called the Banana River. It's a lagoon. And that's a launch. And then what's going to happen is after some time, the abort system is going to take over and remove the capsule from the main rocket. Of course, this is not the SLS rocket, but just a smaller rocket to test the abort system. But it was successful. That was the whole idea.
Seconds, we will see the abort. Abort initiation. Fires 1 and 2 discharge both sides. Mission compression. Control.
So that was your abort. Worked successfully. And then the capsule will jettison away from the rocket itself, and that will fall into the ocean. There you go. There you go. So that was successful, and you see it was jettisoned now. And that's the rocket to the right falling into the ocean. So this was tested.
There's the LAS tumbling a bit, Orion coming down. Everything looking good so far.
On the right hand side is the rocket, and the left is the Orion capsule.
So once the data recorders have been deployed and the vehicle is no longer transmitting data, TC will call test complete.
So as I said, test, and test.
We're about to get ejection of those EDRs.
So that's a testing of the abort system. There are partners all over the United States for this Artemis mission, and you see a number of them are in Florida itself. But all over the state, almost every state has some company working on some aspect of the Artemis mission. Now, I can't talk much about this outpost, the gateway, because we still don't have funding for it. but it's actually very similar to the space station on a smaller scale. And the idea is that it's going to go orbit the moon, and we're going to launch from the Earth, dock with the space station or the gateway, and then from there send the astronauts to the moon. But I think what's going to happen right now is the lunar landers that I'm going to talk about are separate landers that will be launched from the Earth. They're going to dock with the Orion spacecraft, and then from there go to the moon, because I don't think the gateway is going to be built by the time the first humans go to the moon. So this is the gateway. This is the whole idea about the gateway, is to have a number of small structures. Here's the Orion to the right, which will dock to the spacecraft itself. It's very similar to the space station, but small on a smaller scale compared to the space station. But as I said, we don't know have much details about it, because we don't have the funding to build everything. Right now, they're building the power and propulsion unit. The orbit of the lunar gateway is going to be like a halo orbit around the moon. That's the easiest way of actually landing onto the moon, and the cheapest way. So the halo orbits are the orbits that the gateway will be using. So we want to go to the lunar surface by 2024, land on the moon by 2024 near the South Pole. Before that, we're going to send commercial payload services where they land payloads near the South Pole. And then finally, you're going to have a crewed mission which will land humans onto the moon. This is a path to the lunar surface. This is the plan right now, but right now we're going to have the power and propulsion element of the gateway. The Orion spacecraft will be launched from the Earth by the SLS. It will dock to the power and propulsion unit. And from there, we're going to have lunar landers, which will land on the moon with the humans. That's the plan so far. So we're going to use reusable systems to land astronauts on the moon. This is an artist's conception. NASA gave awards to 3 companies to land payloads on the moon. These are not carrying humans, but just carry payloads. So these 3 companies have been given money to land payloads onto the moon. And then the human lander, NASA chose 3 companies to build the human landers, and they'll finally choose one which will land humans to the moon. So this is just an artist's conception of the human landers near the South Pole of the moon. The first one is a national organization led by Blue Origin, also has Lockheed Martin and Northrop Grumman. Blue Origin is going to build a descent stage. There's going to be 3 stages for this human lander, and Blue Origin is leading this development. The second one is called Dynetics. They have another version of a lunar lander, and if you look at it, it's kind of pretty low to the ground, and some mission specialists like this low landing lander. And then you have SpaceX, which are going to use their existing rockets and landers to create a lander to land on the moon, to build one. So these 3 companies are private companies, are being provided funds by NASA. They're not using their own money. They've been provided funds by NASA or the taxpayers to build these companies or build these landers. And finally, the spacesuits. These were the spacesuits that were used by the shuttle astronauts or by the Apollo astronauts. They were for floating spacewalks, not for trekking across a rocky surface. Look at this video of astronaut Harrison Smith, who actually tumbled while he tried to pick up a rock. And if it had torn the spacecraft, he would have died, because it's all pressurized and everything. So we want to have a spacecraft which is more mobile, which can be more flexible, and which is stronger. And here it is. So we have 2 types of spacecraft that have been built. One is called the Exploration Extravehicular Mobility Unit, which is bigger and stronger than the Orion Crew Survival System, which will what the astronauts are going to wear inside the Orion constellation. Here's a quick video of the two types of spacesuits. They're modular. They can fit different types of people. This is the Orion crew survival system. It's not as big and clumsy as the extravehicular unit. And this is the actual extravehicular unit spacesuit. See how big it is. You actually have to step inside it. But it's really more flexible compared to the spacesuits right now. You can bend, you can move your elbows around, you can pick up things. And this is just showing you the mobility of the spacesuit. And you couldn't have done this with the original spacesuits. And of course, it's designed so that it can fit all types of astronauts. And it's modular, so you can have different interchangeable parts. And it's going to evolve it because on Mars will be a bit different. So those are the spacesuits. I'm going to skip some of the slides because I'm running short of time. And I talked about where we are going. We are going to go by 2024 onto the south pole of the moon. I'm not sure of the dates right now. I have a feeling that it might not be by 2024, could be by 2026. But the rocket is almost built, the Orion is built. So we will go to the moon and we will land astronauts, especially a woman, onto the moon very soon. I want to skip certain slides because I want to talk about the problems for lunar dust before I end the talk. And again, I'm going to talk about research going on right now. Some of them are published, some of them I've got from my colleague who has done most of this work. So everything I talk about from now on is work done at our center called the NASA Center for Lunar and Surface Asteroidal Sciences. They are working on different ways of mitigating dust problems onto the moon. This is Apollo 17 commander. What he said was the dust is probably one of the greatest inhibitors to a nominal operation on the moon. I think we can overcome other physiological or physical or mechanical problems except dust. And he's right. Dust is going to be a problem. Look at this Apollo 15 spacesuit again. Look how dirty it is after they landed on the moon because of the dust on the lunar regolith. So dust issues, it darkens the surface, so there's more of heat transfer, and that is bad. It's very abrasive, and actually we have known of astronauts rubbing their shield to remove the dust, and it scratched the shield of the helmets. So this is very abrasive. It has a negative effect on the coatings used to seal equipment in space, lenses, solar panels, and so on. They can actually cause damage to the astronauts' lungs and cardiovascular system. And of course, there's a risking of what's called spacesuit arcing. It's like electrostatic buildup because of this exposure of the dust fields to the space environment. These are some of the issues that we have to worry about. And as I said, this is just last few months ago. Researchers at Stony Brook University have found that compounds in the lunar soil react with human cells and can generate radicals which are known to increase the risk of lung cancer. So if you want to go to the moon, be very sure that we take care of all these issues before we go there. This is one of the a dust shield has been built by engineers at the Kennedy Space Center. It's kind of an electrostatic dust shield. I supported this project 9 or 10 years ago as a seed funding, and now it has taken over, and they have sent it to the space station to study it. So it's called the Electrodynamic Dusting. And the video will explain it. I don't have to say much, but this is more on Mars because on Mars you have a lot of dust storms. And sometimes the dust storms engulf the whole red planet. And you can block the solar panels, which can block sunlight. And that can cause problems with the mission itself. like it did with the Opportunity rover. So you see, scratch the astronaut's visor. So this is the guy Kaye, who I supported years ago to start building this solution to mitigate the dust. It's like electrostatics, and dust will stay away from these electronics. Build an electric shield. So now this is an old video. It has been sent to the space station to see how it works in under conditions of microgravity. So the number of such, I'm going to skip these. It's not so good. We'll talk. I'll skip it. But I told you there was a Center for Lunar and Asteroidal Surface Sciences. It's funded by NASA, and we work with universities throughout the world, in fact, Europe and the United States. And one of the things they're trying to do is to figure out ways of the plume effects of the rockets as it lands on the moon. So I'm going to show you, this is wrong, this is the Apollo 11 descent film. And it's going to show also the imagery taken by the lunar reconnaissance orbiter side by side, just to show you where it landed. I hope it works, yeah. Oh, it's Apollo 15, sorry, not Apollo 11. Apollo 15, but what I'm showing you is, I'm going to show you near the end what you can see with the camera. So it landed in 1971. So here you go. This is from the left-hand side is a view from the camera on the crew. On the right-hand side is the same area taken by the LRO spacecraft, just to show you a better version of the landing. Here it is about to land. And look what happens when it's about to land.
50 at 3. Cross pointers look good. 40 at 3.
Landed close to a crater. Look at this. Look at all these streaks. Now you can barely see the surface. And that's what happens when you're landing, is the plume effects is blowing dust out.
20 at 1. 15 at 1.
Look at that.
-1. -1. 6% fuel. 10 feet, -1.
And as it comes closer and closer,
-1.
a lot of this dust is being ejected away, and you can barely see it. And that's a landing.
Okay, you're moving about.
So you see the issues. This is again from Apollo 15. Look at images looked at different times when landing. And look where it landed. It landed very close to a small crater. It was actually tilted backwards a bit because they couldn't see where they were landing in the end. So you want to be very careful that we figure out a way of mitigating this plume effects as future rockets land on the moon. And the future landers are going to be more powerful than the Apollo ones. So what happens on the Earth as a rocket lands or as a rocket takes off, the plume of the ejector is because of gravity is collimated. But on the moon, because you have 1/6 the gravity is almost a vacuum, the whole plume is spread out. It is not collimated like on the Earth or it will be on Mars. It is all spread out because it's almost a vacuum environment, and that's what causes the effects of the dust. So as the lunar lands, okay, the plume is expanding in vacuum instead of being collimated. So in fact, as the lander lands, you might not get a huge crater right below the lander, but you might get small craters away from it, because as a lunar lander lands, there's an ejector of material going away. And there's this shock wave, which results in small craters away from the landing site. So that's the issue with the landing. Here's some simulation which shows the gas density. Here's the rocket landing, 0. Look, here's the gas density is high is green, blue is less density. But look over here, you have the highest density of gases. That's why you have the small crater over here. This is the gas velocity, the bottom screen. Again, you see this is where the rocket is going to land. And here the gas velocity, again, the gas velocity is very high over here. But you see, it's like a sheet. It's not along the surface, it goes up a bit. And that's where you have the highest velocity and the highest density. So there's as the rocket lands, the ejector is blown away in a sheet. Sometimes they have seen this fist-sized rocks being blown away at about 60 miles per hour. So these are rocks being blown away. So if the big rocks nearby, some of the rocks can be the size of a fist and about 60 miles per hour. If they hit something close by, that can cause a problem. So that's why it's important. So I want to talk to you very quickly about this Apollo 15 mission. And it landed very close to an original rover called Surveyor, a mission that the US landed a long time ago. The Apollo 15 landed very close to it. So what the astronauts they went to the Surveyor spacecraft. This is the camera. They took the camera, brought the camera back to the Earth. And this guy called Phil Metzger, who was a scientist at Kennedy, he got parts of this bottom part of the camera, which is this part over here. You got segments of this, and they were testing that segment. And if you look, here's the UVC on the left-hand side, all been sandblasted. This spacecraft Surveyor through was a few meters away from the Apollo 15 as it landed. And the base of the camera has been sandblasted by the ejector from the rocket itself, from the lander itself. And the right-hand side shows you a electron microscope. The left-hand side is the one which is not sandblasted, and the right-hand side is where it is sandblasted. So the grains have melted, have fused together. You also see a crack over here. So it is pretty dangerous for objects close to the landers when they land on the moon in the future. On the right-hand side, they did some testing with glass using a lunar simulant, and it actually almost cracks open the glass. So these ejector that will be created by future lunar landers will create problems. And they found out that the stream of material which hit Surveyor was not the actual ejector, but particles that were deflected off the main ejector sheet. And the reason was because the Surveyor was in a small crater. If the actual ejector had hit Surveyor, there would have been 1,000 times more damage than actually there was. And here it shows you, here's the Surveyor. It's about, let's see, I think 9 meters below the level of the Apollo 15 lander. So the Apollo 15 ejector went over the Surveyor spacecraft, and only the particles which were scattered came and hit the Surveyor spacecraft. And even that scattered particle caused so much of a problem. Imagine if the whole ejector had hit the spacecraft. And again, imagine if there were more powerful landers landing onto the moon. So as I said, the ejector, they go mostly in a thin sheet, not parallel to the ground, but inclined a bit. And there are some exceptions. There's some scattering, which will allow some of the materials to fall lower down. The terrain shape will cause a difference in how the ejector is going to be thrown out. And of course, at the end, when it lands at the end, there's a final shock wave. And that also will create a problem. But most of the ejectors mostly is in a thin sheet. These are some simulations which shows that the dust particles are ejected out about 1,000 to 3,000 meters per second, about 3 kilometers per second. And the lunar escape velocity is 2.4 kilometers per second. So most of the fine dust might go around the moon. It'll be, or some of them will escape the moon. Now the Apollo missions had aerosol as the fuel, and the speed of those ejector of the gas was about 3 kilometers per second. But if we use the landers right now, we use methane and liquid oxygen, there the velocity of the gases will be a lot higher. So the ejector of the dust particles and the sand from these future missions will cause the dust particles to go further away and at a higher speed. So we're looking at simulations done by looking at various different landers. Hope this works. This is, again, I got it from Phil Metzger. This shows you an animation. Hope it works. So yeah, this is a 40-ton lander on the moon. Initially, the ejector goes sideways, but then it goes all around the moon, and it takes 1 hour before the particles come back to its initial position. This has been sped up a lot, and it's 1 week's worth of simulation. But as I showed, it went all the way around the moon, and it came back. So that is, and remember I said we have the gateway is going to have a halo orbit. Let's see if this works or not. This is causing me a problem. I'm sorry, it's not, oh, there you go. So this is the moon, this is the halo orbit, and here's the ejector going away. But look, the ejector from the moon is going to intersect the halo's orbit, the orbit of the gateway. So when the gateway is being built and it goes around in orbit around the moon, twice in a week it's going to be intercepted by this debris or ejector from the moon. Now, it is not as bad as it looks like over here, because most of the ejector will be very fine dust particles. It may not be as bad as this shows in the simulation. And this simulation did not take into effect other physical factors like the solar wind. That will also cause other issues, but they're working on that. This is being working on right now on some of the simulations. I'm going to put more physics into the simulations to see how this ejector is going to cause problems. And the best available estimate of soil ejection for a 200-ton lander will be about 1,000 tons of material which will be ejected out. So that's quite a lot. It's almost equivalent to an average apartment in Kolkata if we tightly pack it with dust. Tightly packed. That's the amount of material that you can have in one of the large apartments in Kolkata. So there's a lot of soil ejection because of these landers. So now one of the reasons we're doing this to come up with guidelines to protect the heritage sites, the other Apollo missions when they have landed. You don't want some other rocket to land near one of these Apollo 11 landers, Apollo 12, 15 landers, and destroy them. So they thought that they would have a 2 kilometers boundary line where you can land beyond that. Also, the other guidelines is trying to come up with this trajectory or plume reflection plane so they can eject the plume further up away from the surface. Landing behind natural terrain barriers, or hopping inside the 2 kilometer radius as long as you don't hop more than 50 meters above the surface. So these are the guidelines that the US has, as NASA has. You cannot tell other countries what the guidelines are. You cannot force it onto them. But you would hope that international cooperation is such that when other countries land, if they land near some of these heritage sites, they will follow some of the science that has been developed, and we don't destroy the heritage sites. So potential scenarios for future conflict. I don't think this is going to happen, but what if a country or a state places a sensitive telescope in the center of a zone on the moon, which is full of resources? And it's a tactic where they say, okay, I have this telescope, you cannot land next to this telescope. But the area on the telescope has all these very good resources. Or they put this outpost on what is called the peaks of eternal light. These are near the South Pole, where if you build a tower, you have sunlight all year round because of the height above the ground and near the South Pole. Another country says, oh, your country landed landed close to my hardware and you destroyed it. Or you're saying instruments on an orbiting spacecraft are ruined by sandblasting by a lunar lander. So these things can happen in the future. So we need to figure out a way to come up with guidelines that every country can use to safeguard all these sites on the moon. One of the things that they're working on in the center is lunar landing pads. We have some kind of a landing pad to, so suppose you have a habitat that you have built on the moon. You want to have a landing pad close to it, where when you land, the landing pad will block the ejector hitting the habitat. So, and I'm going to stop by this last thing. It's the 1967 Outer Space Treaty. It's very old, okay? The Space Treaty says that no one owns outer space, okay? But look what's happening now. We have better technologies. We have better biological technologies, chemical technology, aerospace engineering. We have a number of nations now who are, in 1967, it was only USA and Russia. But now you have so many nations, China, India, Japan, the European Space Agency, Israel. They all want to land on the moon. So we have to have a better treaty. Now you have private companies, okay? So when private companies land on the moon, do they say this is my part of the moon? So we have to figure out a way to come up with a better space treaty than what we have right now. And hopefully that they're going to work on having an outer space treaty by the UN, which can cover all nations, not just the US or not just Europe. So I think I've taken a lot of your time. I'm going to stop here. If you have, do I have any time to show a 3-minute video, or my time is up?
So please go ahead. Please go ahead.
I want to show you this video. I like it. I think this is our future. This is for the kids in the audience. May not be you, maybe it be your grandkids, maybe your kids. Let me show you. It's called Wanderers. It's narrated by Carl Sagan, and it's an animation, but it uses pictures of actual areas in the solar system where we can settle in the future. So let's see if this works. Yeah, it's about a 3-minute video. So it's a recreation of actual places in a solar system.
For all its material advantages, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood.
This is the actual picture of the Earth taken on the space station, but you have other animations on top of that. So there is some artistic license over here. This is over Jupiter.
We invest far-off places with a certain romance. The appeal, I suspect, has been meticulous.
Enceladus, one of the moons of Saturn,
as an essential element in our survival. Long summers, mild winters,
rings of Saturn,
harvests, plentiful game. None of them lasts forever. Your own life, or your band's, or even your species might be owed to a restless few, drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds.
because this is Mars.
Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, I am tormented with an everlasting itch for things remote. I love to sail forbidden seas.
This is Europa, moon of Jupiter. This is Titan, moon of Saturn.
it's a little early. Maybe the time is not quite yet. But those are the worlds promising untold opportunities that can. Silently, they orbit the sun, waiting.
So I think this is the future. I think I'm very confident that we are going to go to these places, but we start slow. We're going to the moon, then go to Mars, and go to other objects. And this is for the younger kids in the audience. You are going to be a part of it, not so much us, but you. And we will be settling on other worlds. That is going to be a future. Maybe not this generation, but generations from now on. So what I hope to give you was just an overview of what NASA is doing for future exploration by focusing on the moon right now. It was not intended to be a technical talk. I don't have the capability to give such technical talks. It's not my field, but the whole idea was to get an idea of what's going on. And I think I can take questions, or later on, if you want, you can give them my email address, and they can always email me questions. Don't expect an answer back in the next second. Just give me some time. But if you tell me that you attended this talk and you have this question, I'll gladly answer your question. If I don't know the answer, I'll find it from someone else.
Thank you, sir. Thank you for this extraordinary experience. We simply had no idea of the details of the Artemis project. Sir, a very heartfelt thanks from all of us who have attended this webinar today, and from all of us at Skywatchers Association. I'd like to tell you one thing, that regarding the question hour session, Dipankar.
Yes, sir.
We give Dr. Mukherjee some rest. In the meantime, you go through the questions in the chat box, and sir, what we'll do is, Dipankar will go through the questions the people have posted in the chat box. He will choose some of them and will ask you the questions. So to do this, we'll get some time and some much needed rest for Dr. Mukherjee.
No, I'm fine. Don't worry. I do this a lot, so it's okay.
Now,
And don't have to censor the questions also. It could be a controversial question, and I'll answer it the way I answer it. So you don't have to censor questions. I think it's important that, if you have something in mind, just say it.
Dipankar,
Yes,
you
sir.
go through the questions. In the meantime, I'd like to refer to a very interesting incident which concerns Dr. Mukherjee, of course. So I told you at the beginning of the session that I did attend one of your lectures when I was a student of the evening course at Birla Planetarium. I remember the incident. After the lecture, after the session was over, me and a friend of mine, we were outside at a tea stall. We were having tea, and you had just left the planetarium and was going towards your car with your secretary. And at that moment, I remember my question, which I asked you in the hall, that was regarding Apollo 13. And on that, the place was a bit dark, but still you recognized me and asked me, aren't you the person who asked me the question about Apollo 13? I said, yes, sir. Then we had a chit chat. And then again, I said, sir, I have another question. And you told me another question. I said, yes, sir. The question was, which is so pertinent to today's lecture. I had asked you this about 8 to 10 years back. The question was that, sir, we know that the sun is going to end in a definite amount of time. So will the earth. My question is, are we doing nothing about it? You gave me an answer which was very similar to what you showed us, what you told us in your lecture today, that we are not sitting idle, we are definitely doing something. This incident, I remember very vividly. Now,
I do remember too. I do remember talking to you.
Oh,
I won't recognize
thank
your
you.
face. I didn't recognize your face, but the conversation, yes, I do remember.
Thank you, sir. Thank you. By the way, Dipankar, are you ready?
Yes, sir.
Okay.
Okay.
Just before you start, since we are the final stages of this session, I'd like to tell everyone that this webinar is the last in the series of webinar that we were organizing, that Skywatchers was organizing. This journey started with Professor Biman Nath, then with Professor Soumitra Sengupta, then Professor Dipankar Banerjee, then Professor Sujan Sengupta, and finally Dr. Jaydeep Mukherjee. We are indebted very much to each one of you. Thank you very much. Dipankar.
Okay, sir. So the first question was from Bornini Bhattacharya that, sir, can you kindly explain the difference between moon walkers and robotic landers with respect to moon landing?
Yes. So NASA has two types of landers that they're working on. One is just a robotic lander to land on the moon carrying payloads. There'll be no humans on the landers. How that's going to be done, we still don't have any details as yet, but it could be launched from the SLS or it could be launched from SpaceX or other companies. But when you launch a robotic spacecraft, the issue is a bit different. You don't have to be so stringent with risk, apart from the cost. Whenever you have humans involved, then you have to have a problem with all the risks that you cannot take. So the robotic landers will carry payloads, scientific equipment to go and land near the South Pole and do experiments. The human landers are built differently. We are going to take astronauts from the Orion from the Earth in the Orion capsule. One idea is this Orion capsule will dock with the gateway, and the human lander will come to the gateway. The astronauts will switch from the gateway to the human lander, and the human lander will land on the moon. And then again, bring it back to the gateway. I think the gateway will not be built on time. So initially, the chances are that the human landers will be launched in a separate rocket, either by SpaceX or by NASA or by some other organization. And they'll, mostly by SLS, I would think. And then they would go and dock, the landers will go and dock with the Orion spacecraft, which is going to orbit the moon. And from there, they're going to go and land on the moon. So that's the difference, is having humans and not having humans. And you're going to start with sending robotic landers, and then you're going to have human landers.
Okay, sir. The next question is from Shurup Ghosh. He's asking that, sir, why NASA has not arranged any human mission on moon after Apollo 17?
Money. So it had become very expensive. And then they thought that a cheaper way of doing things would be to focus on what we call low Earth orbit. And that's what they did, is focus not because of new technology, but as I said, remember, everything that we do here, whether it's NASA, it's dictated by the current political organization, the administration. So each administration will have a different ways of looking into things. They're going to dictate to NASA, then NASA come up with plans, talks to scientists and come up. For example, the Artemis mission was dictated by the president that we land on the moon by 2024. But it's up to Congress to support it. So in the past, even though we didn't land on the moon, some of the interest was lost because of other issues going on, and they focused more on low Earth orbit. But right now, because we have this directive to go to the moon, NASA is focusing again to go to the moon. Look at the European Space Agency, look at India, look at China, look at Japan. They're all focusing on the moon because we think now to explore other objects, to settle on other objects in a solar system, we need to focus on the moon. So in a short, the answer was lack of funds. That's it.
Okay. The next question is from Kritika B. Dotto. She is asking that irrespective of when people can move to moon to settle down, how do scientists deal with the mass population actually? How shall the whole population can be transported there?
You cannot. That's a good question. You cannot. You cannot. I'm not saying we should abandon Earth. We cannot abandon Earth. But you have to start slow. And that's why if we need to have a mass exodus, in case things get so bad, which I don't think it'll get so bad in the next 100, 200 years, but in case things get very bad, yes, then we will have a mass exodus. But right now, we don't have the technology, nor we have the infrastructure to do any mass exodus. So it's going to be a small group of people who will be doing it. All depends who is doing it. If it's the government doing it, there'll be some rules. If it's a private company doing it, there'll be a separate set of rules. I don't believe private companies will have the guts to do it, really. Now, except SpaceX. SpaceX is led by a person who thinks very differently. But it's mostly going to be governments which are going to lead this exodus. Private companies are interested in, say, asteroid mining of resources. I know that there are resources on some of the asteroids, which if we can mine and bring it back to the Earth, a diamond on the Earth will be like glass. So again, to give a short answer to your question, no, we cannot have a mass exodus right now. We have to start slow and test and test and test.
Okay, thank you, sir. The next question is from Jaydeep Pal. Sir, how we know what is inside a planet or a moon?
Well, a number of techniques. One of them is radar. One of them is the radiation that comes out. One is reflected sunlight. One is we have in some places we have been to the planet when you have gone bituminous on the planet. From the spin of the planet, there are various ways we can figure out what's inside the planet. And of course, we know what the Earth is, so we can always extrapolate to other objects in the solar system. But mostly the indirect ways, we're not penetrating and we don't have X-rays to look what's inside. We see what's on the surface, how the object was formed. In the case of the moon, we figure out from simulations that lighter elements come to the top, heavier elements sink below, and that's what you see in the rocks. So it's a combination of different observations and techniques, not just one, that gives us an idea of what's inside a planet. Earthquakes, moonquakes, planet quakes, that will tell you as the earthquake moves through the surface, through the rocks, they propagate differently. And by studying those waves, you get an idea of what the rocks are underneath the surface of a planet or a moon.
Okay. Before going to the next question, I just mentioned that to all participants that feedback links has been provided in the YouTube live stream and here also. So please fill up the form before leaving our session. Okay. The next question is from Adrit Nag, that Cassini provided us with a picture of erupting geysers from the surface of Enceladus, and Galileo spacecraft has provided us with the evidence of water on Europa. So how can water exist on so distant worlds?
Well, if you look at the way the solar system formed, okay, you have this huge ball of gas and dust, okay. The gas was hydrogen, the gas was helium, and there were some other phases. And then you have the small particles very close to the Earth, because I'm talking in a very layman's term, because it was very hot, very close to the Earth, the gases evaporated, okay? They were given so much velocity because of the temperature that they escaped. What was left behind was solid particles. But very close to the sun, water could not exist because it would evaporate out. There was no ices because it would melt into water. Earth is in such a place that you have the right temperature where water can exist, okay? That's why we have water on the Earth. If it was very close, Venus or Mercury, all the water evaporated. Where did the water come from? It could have come from comets, it could have come from meteorites in the past, because there is water everywhere in the form of molecules. Further away from the sun, it was very cold, okay? So you had the solid particles, which are icy particles, because very far away from the sun, the temperature was not high enough to melt it. They formed the rocky planets. And then they were covered with this huge gas of hydrogen and helium. That's why the outer planets are huge and gaseous. But the moons around the planets were formed from the material around it. And those materials were actually ice. They had ice in them. They were cold. So when they formed, there were some ice particles in the rocks, in the material, which, because as the moon was swarming, it was spinning, it was compressed, it formed oceans. So all these Europa series in the asteroid belt, Enceladus, even Pluto, they all had water in the form of ice in them, in the rocks, in the particles. And then they actually formed and then melted and formed the oceans. So I think it's very common that we are going to have oceans in other planets, in other moons. They're very, very common.
Okay, hope you got your answer. The next question is from Mr. Shamabroto Das, that does the moon dust or moon itself has any radioactive radiation?
Well, yes, there is, but it's not that we are going to have problems with it. But there is thorium, there is potassium, and these radioactive elements that generate heat, and they have been melting some of the rocks. So yes, there is radioactivity, but not in the terms that's going to affect us.
Okay. The next question is from Shomindro Basu, that why is Dragon space capsule is not used instead of Orion?
Because the Dragon space capsule can only take you to the space station. You go beyond low Earth orbit, you go beyond the Earth's magnetic field. You go beyond the Earth's magnetic field, you have to shield yourself from radiation. You have radiation coming from the sun or the solar wind. You have cosmic rays coming from the galaxy. These are very energetic radiation. The Dragon cannot, it's not built to withstand all the radiation. The Dragon has been built to go to the space station, which is 400 kilometers. That's why the spacesuit is different. So the Dragon is a very good example of a spacecraft, and SpaceX has done wonderful things with new technology, but they cannot go to the moon just because we don't have the. I didn't show you pictures, but the Orion has an extensive tiles also at the bottom as it comes down from the through the Earth's atmosphere. It's going to shield it, but mostly the main thing is the radiation that the Dragon cannot stop if it goes beyond the Earth's magnetic field to the moon. I'm not saying they can't do it, but they have not done that because the idea was to go to the space station.
Okay. There is another question from Mr. Omlan Kushum Molla, that, sir, if dust is a problem even during landing, is there any chance of mitigating it by spraying the landing surface prior to landing by some kind of substance like hydrophilic substances, and the dust particles stick to themselves?
That's a good point. You know what? I haven't thought of it. I need to ask this question to some of my colleagues. I know the thing of building landing pads, which can cause, but I think what you're talking about is going to be, first of all, where is the solution going to come from? The spray. That means you have to take the spray. We need a huge amount of this liquid or whatever the spray is going to be from the Earth. Anytime you take something from the Earth, you increase the mass of the rocket, you extend the cost of the rocket. So unless we can create that spray on the moon itself, which I think we can do in the future, or not right now, I don't think we can spray or doing anything because it won't be cost effective. But I haven't thought of it. I'm not a geologist. I'm going to, whoever asked me the question, can you send me an email? So I'll try and find the answer whether it can be done, and I'll give it to you because I don't want to give you a wrong answer.
Okay, thank you, sir. So with this question, we conclude the question answer session for this webinar. If there are a few more questions, if we get them from the participants, we will surely mail it to you so that they can get their answer if you are allow us to do so.
As long as they say that you were in the webinar, I'll answer your question. So I get a lot of weird emails from all across the world. I don't know.
Okay. So before formally ending the session or formally going into the formal Thanksgiving session to the people or the attendees who are present right now, I have a piece of information. Now, Professor Dr. Mukherjee's lecture today, the center point was the moon, the Artemis project, the moon. Now, NASA has a very unique way of celebrating the moon. That is the International Moon Observation Night. Now, the International Moon Observation Night, NASA decides on the dates, fixes the date, and makes it known all over the world so that people can participate and observe the moon on the same day from all over the world. That is, this year the date is on the 26th of September. It's a Saturday. Now, Skywatchers Association will be joining the movement. We have registered the event, and this year's event will be on a virtual platform. And we plan to have a series of activities for, say, a 2 or 2.5 hour session. There will be an online virtual on the virtual platform online moon observation live, plus a 2.5 hour interaction among all the attendees regarding the moon. We will be basically sharing our information and celebrating our nearest celestial neighbor, our own moon. So please note the date. It is the 26th of September, and we would love to have all of you with us. Dr. Mukherjee's lecture today is the beginning, which we want to finish it as a final stage as the International Moon Observation Night. Now, I'll formally hand over the session to Mr. Polash Chatterjee. Polash will be delivering the vote of thanks. Polash.
Thank you, sir. I am giving the official vote thanks. On behalf of the Skywatchers Association, I would like to thank Dr. Jaydeep Mukherjee, our estimated speaker today, for this wonderful lecture. Thank you, sir, for enlightening us. It is truly inspiring to know about the humanity's ways to know the unknown and to go beyond the limit. I also express my gratitude to all the participants who have been here today. Most of you probably following the series of webinars regularly. We thank all of you for making these online events a success. Last but not the least, we thank all the Sky enthusiasts and all wishes of the Skywatchers Association support. And with this, I conclude this session. Again, thank you, everyone.
Thanks. Can I stop now?
Thank you, sir. Thank you, sir, for being with us. Thank you very much.
Thank you very much, sir.
Okay. I'm welcome. I enjoyed it.
Hello. Sir, one request.
Yes.
If you will join on 26th of September with us. Again.
That is the International Moon Observation Night.
Moon
Yes,
Observation Night.
on that day. Yeah.
There also an invitation for you.
26th.
26th.
That, but and for all of you present here, you all are welcome to join us. It will not be of the structure of a webinar. No way. We will all join, share our views, and celebrate the moon. We will try to answer our own questions. Anyone has a question can post it. If we have experts with us, they will be more than happy to answer. And we'll try to organize some activities also. The details, we'll be sharing it very soon. Just like to refer to it that last year we had put up several telescopes at the Dakshinapan shopping complex, which is a shopping mall here, and we could show the moon to about 400 plus people. And fortunately, we had Saturn and Jupiter that day very clearly visible. So that was a treat. So this year, because we cannot do it on a personal basis or we cannot put up telescopes for public viewing, we'll do it on a virtual platform. And whenever we publish the details of it, you can contact us on our Facebook, you can mail us. If you have any suggestions of how we can make the program a successful one, or you can suggest anything new, innovative, we'll be glad to incorporate that also.
So I just wanted to say, the 26th, send me an email.
I'll share you that. So I'll share you.
Is it a weekend?
Sir?
Yeah, 26 is an weekend.
It's a Saturday.
Oh, that's okay. Yeah.
26 is a Saturday, and we
Yes,
plan to start at about half an hour later from now.
Okay, that's
the
good.
time was 5:30 or 6.
That's very good.
And we'll be very happy. Rather, I was thinking of if people come up with serious questions, then we might be at a loss. So with you around, we can be rest assured that we can answer those questions.
Yes, I'll join. No problem.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Thank you, Palash, for thinking very timely.
Okay, can I log off now?
Sir. Yes, sir.
Yeah.
Yes.
Yes, sir. Yes, sir.
Thank
Thank
you.
you very much, sir.
Thank you very much.